Next, we have Solomon and Sonja, and he is a reverse engineer, software developer, and instructor in computer science. His current research areas include remote admin tools, command and control protocols, and digital forensics. So please welcome Solomon and Sonja.
Thanks. Thank you, everyone. Thank you very much for having me. It's a blessing and an honor to be here. So hopefully we'll have a good presentation today. And just as she said, I'm Solomon and Sonja, and our presentation today just goes over Splinter the Rat. So it's how do you create your own custom remote administration tools or botnets to control the network, and then more importantly, since you have this knowledge of how to exploit the network, how can we turn this into how do we better defend and secure our computer systems? So let's proceed with our presentation here. Disclaimer. I always do the disclaimer just saying that please do everything for secure purposes. It's just saying that, hack for good. Hack for good and not for evil. Okay, disclaimer is done. Just in case, because some of the things I wrote, it's like, I'm afraid to run it on my own production system simply because, and the tool that will show the difference in enumerating or listing every single file in the computer system and deleting every single file in the computer system is just one byte. So I'm like, oh, that's kind of dangerous. So, again, if you choose to use these tools or various things, just please be careful and use them for good and not to actually destroy other people's computer systems. Here's what to expect in our presentation. It will be obvious what we'll cover, but this guy, the live demonstration gremlin, he follows me on every presentation because for some reason, whenever you have presenters up here, and they do a live demonstration, sometimes it crashes. And you say, oh my God, how's this guy going to come up here and he does stuff that doesn't even work? This junk's stupid. No, it's just that for whatever reason, stuff crashes. So hopefully it won't crash. I spent like 4 or 5 hours this morning trying to fix just one small piece in the code. And I also broke my own rule. I break it every time. I always say never program and demonstrate something you just programmed without testing. And I always say never do that. Yeah, I would do it. So I did it again this morning. So if something crashes, I'm sorry. I will get the most updated version uploaded to GitHub. Okay, so research motivation. And actually, Joe Best, he kind of hit on exactly the reason that I do this. And it's simply, at times, the best way to fortify your defenses is to understand its weaknesses. So that means if I want to better secure my enterprise network, I should be red teaming this network and trying to penetrate it as often as possible so I can find the gaps and then I can better secure it. From data loss, data theft, malware, etc. So understanding how malware is created gives us a better idea of what it looks like on the network and also security implementations to deploy to better secure our systems. And finally, just that's exactly as Joe said, bridge the gap between botnet creation, between offense and defense. Okay, so what is this botnet that I speak of? Well, I will just give you the terminology so that we're just on the same page whenever I say terms in this presentation. So a botnet, by the Book of Solomon, that's me, is simply a network of autonomous agents that synchronize with the command and control server to execute commands and to also help us complete our remote exploitation of that victim system. If I talk about the controller, I'm simply talking about us. We are the controllers. We're the people in command of the botnet. If I mention the dropper, that's simply the agent that configures the environment. It sets up the true implant that will connect over to my command and control server, and then it goes away. And finally, the implant is the true agent that I use to connect to the botnet to exchange commands and to execute everything that is released from the controller. So now, if we want to load our hacking toolbox, what items or techniques should we know about whenever we want to go out and create our own botnet? Well, the first one, socket programming. We're definitely going to have an understanding of how do I instantiate various sockets in order to exchange information across these sockets. The next thing is multi-threaded applications, multi-threaded programming, and also the use of worker threads. So I will use threads to handle simultaneous functions on the victim machine all at the same time and then return responses back to me. So that's just why threads is very important to understand. How am I going to create threads, how can I program them, and interact with them on the victim machine. Next, native operating system commands. I should understand if I have an agent listening on an infected machine, how can I interact with that operating system in order to have it do exactly what I want? Next, Windows Registry, we'll be modifying some things in the Windows Registry, execution of commands, file transfer protocols, and that's actually important because with Splinter, the tool that I created, I actually created it by accident. It just happened, like I stumbled upon Splinter, and so I created it, and now it's released to everybody. Instead of using the normal FTP that has various commands, I implemented my own file transfer protocol because I was actually exploiting an enterprise network, very large. And then the normal FTP commands were stopped. I said, okay, fine. What happens whenever a hacker denies access to a system? You say, game on. And now you go off and create your own thing that you want to do. So that's what I did. Programmed it very simple, and you'll be able to see this in the source code. I released an older version and a newer version. Hopefully will come out this weekend. I just have to sleep today. And then finally, process instantiation. How do I create new processes on that infected machine to carry out every single task that I command? So now, MacGyver. I used to watch MacGyver, when we were younger. And so one of the important things with MacGyver, he can literally take this Coke can and also this Lay's bag of chips. He can go off into a closet, then he'll come up with like a rocket launcher and a grenade. Like, come on, how is that possible? Well, he effectively uses the tools that he has at his disposal. So that's what we're going to use, the tools that we just mentioned here, in order to create our own botnet. So, if we want to carry out our own exploitation, here are the actual initial steps that I went through whenever I created the system. The first thing, I opened the server socket. My server socket simply allows me to receive additional sockets on my controller, so I can handle multiple agents at once. The next, establish a connection. That's from the implant that connects over to the controller. As soon as I instantiate a new socket over to the controller, now I'm able to open streams, reader and writer streams, so I can send commands, interact, I can read information from that buffer, execute, and then send it back. Finally, initialize various work address to handle additional tasks for me. Package and send commands, parse the commands that are received, and then I flush everything back from the agent back over to the controller. Here's some pseudo code in case you would like to review the slides. I'm not going to go over the pseudo code because, in our own free time we can see, well, how did we put it together? I'm going to release the real code, so I'm just leaving it in the slide so it can be helpful at another time. And also, I just don't have time to cover everything. So if we understand the botnet concept that I kind of alluded to earlier, it's simply I'm going to connect over from an implant to my controller, send a command, the controller receives the command, the implant, and then it sends it back to the controller. If you understand how to do this effectively for one agent, with the same program, you understand how to do it with two agents, and actually you understand how to send commands to multiple agents simultaneously, all from the same controller. And that's actually how we establish our own botnet. Simply a network of zombie machines receiving commands, executing the commands, and sending it back to me as I would like. So where do we begin? Okay, I'd like to just give another overview. So again, we're all on the same page. Whenever we go about talking about hacking a computer system, generally, almost always, we start out with reconnaissance. Let me gain information about the systems I'm going after. Then let's scan, let us see potential vulnerable entry points into the system, and finally, let's penetrate. So Joe, when he said you had 3 steps, one was get in, act, and then stay in. So this is how we initially try and get into the infected machine. Now, after we penetrate that system, this is obligatory. It's obligatory, okay? That's your happy dance. You have to stop dance because you actually gaining access to a system is not that easy. So as soon as we penetrate the system, we complete our happy dance, and then we continue with the remainder of the exploitation. And this actually depends on what is the purpose of the attack. Are we going to pillage? Are we going to destroy the system? Are we going to pivot to other machines? Or are we going to paralyze any infected machine that we can find on the network? And then, if we want to stay in, how do we go into stealth and persistence, and also covering our tracks? So let's take a look at using a dropper. This is the dropper the concept of a dropper pictogram. I like pictograms because I like to draw things. If I draw things, I can explain things. If I can explain things, then I can develop it. And so that's why I include pictograms in our presentation. So here we are. We have the dropper. It comes and it finds some way to exploit that infected machine. As soon as the dropper exploits an infected machine, it reaches out to the real domain that is serving my additional malware. As soon as I serve additional malware, I get it onto the infected machine. I configure it. I now execute the implant on the victim system. Then the dropper goes away. He removes all presence that goes ever into that computer system. And now the implant handles the remainder of the exploitation with the controller. Okay, this is hard part. So 2 days ago, I think, I was wondering, in Splinter I created a way that it has a Visual Basic script that if you were to enter just a few commands, it gives you actual source code that you can implement to handle various dropper functions on a victim machine. But instead I went out and programmed another one, and so that's Aardvark. I haven't released it yet because it's brand new. So as soon as I do release it, you'll be able to see it. So the main purpose of our dropper, again, is I would like my botnet to be as dynamic as possible. And this is, usually your implant will be much larger than the dropper. The only function of the dropper is reach out to my infected domain, grab the most recent implant, configure the system, and then go with it. So that's why I created Aardvark to do this for us. And now, let's see, steps, configure, no. Okay, let me just show you. One of the things whenever you want to create your own botnet is we need a server. So we need a server that can actually tell our dropper how do I grab the most recent implant, how do I configure it onto that computer machine. So I found out that, well, GitHub will allow us to do this. And if you go to our GitHub site, which is github.com/Splinter botnet, go into logs, and then update log. I believe it's update log. Yes. Okay, so this is the one. If I go to raw. Okay. If we're looking at this, and intentionally, it's unencrypted, and I also include just previous versions, so if you wanted to make Aardvark grab any version that I have up there, it will do that for you automatically. So right now, this is just commands that the dropper will implement, and the most important is the website. How does it know where to download the latest version is right here. Okay, so let's see that in action. If I bring up Splinter, this is Splinter the controller. I have a few tutorials on how to run it and how to start it. I won't go over that now because we've already been in 13 minutes and there's a lot of things that I'd like to show. So as soon as we get Splinter running, if I click on connection status, I can come over here to active, and I can see all of the systems that are currently connected to the system, are currently connected to the botnet. And right now, we don't have any infected machines. So if I go over to this Windows Implant, and let's see, Aardvark. Okay, if you use Aardvark-H, you can see all the help options, and new options will come as soon as I release the updated version, because this one hasn't been released yet. But what I want to use now is, I'm going to say Aardvark automatically reach out to GitHub, grab the most current implant version, configure the environment for exploitation, and then connect back to the controller. So that's the main purpose of the dropper that I want. And if it is successful, I should receive a new connection on this side, which there are no connections here. So this is really, really, really live, and I hope it's going to work. So let's go to, oh, there it is, -I. I'm just going to use the -I feature. So if you enter Aardvark-I, it will go up to our main GitHub site. And then I give it the parameters to connect over to the controller. So my controller is currently at, right here, 192.168.223.1. So if I enter that here, 192.168.223.1, I'm just going to port 88. If that is successful, it is actually trying to download. Let me move this. Oh, I was too fast. Okay, sorry. I wanted to slow it down so we can actually see what's happening. But pretty much, the dropper went up to GitHub and grabbed the most recent version of our implant. Now we're connected back to the controller. One of the options that I put into the controller is geolocation. So can we derive where all of our infected machines are? So if you click on that and you click on Google Maps, hopefully it shows a relative location of where I can derive where we're close to. From Alabama, are we near this highway? I don't know, 431? Okay, so at least that's good. Because I don't know, I just tell the program, okay, go out and do it. Can I switch computers?
You can try.
Okay, yeah, I'm going to switch computers. I just did that one because this one gave me a warmer fuzzy whenever I was working on it earlier. Okay, so that was a demonstration that we just finished, connecting dropper into the system. But actually, this one is not, I don't have my implant connected. So another option I give you with Aardvark is to reach out to your own domain. So if you own your own computer system or your own malicious domain, you can give it the direct commands to download for you. So I think I have it here. Yeah, aardvark, if you use the -dx option, you enter in the full address to the implant, and then the name on the infected machine, you enter in parameters, and this one I can show you a bit better. Okay, so I'm using just HFS to serve my malware, so this is the malware right here, splinter.exe, and if it does work, I will get a new connection on this side. So let's go ahead and execute it. Let's bring up the web. And of course, it's not going to work. I might switch back to the other laptop. Okay, I'm not receiving the connection as I expected. Can I switch laptops again?
We can.
I'm really sorry. That's a live demonstration, yeah. Okay. Yeah. Okay. All right. We'll continue. Okay. So just additional options on how you're going to run aardvark, and we just finished the demonstration. Okay. Payload migration. So one of the things whenever we actually create our own botnet, something you should keep in mind is that I want to be able to handle additional exploitation on my computer machine, and not that I limit my botnet only to using my own command. So in particular, I just care to use Splinter only to maintain access to a system. But if we really want to exploit that system, let us say we want to use Armitage or Metasploit or any other program that you want to upload to the system. How can you go ahead and do so? Well, I created a payload migration in order to let you do this. So how can you actually migrate new payloads to the infected machine? So here we are the controller, we have access to the infected machine. And sometimes, let's say we have Metasploit and we would like to gain access to that machine as well. So if I already have access on an enterprise network, if I'm on Armitage or Metasploit, and I try and connect to that machine, it's going to be blocked. I should expect it to be blocked because there are various boundary applications and architectures that's going to be in place. But instead, since I already have access, now if I can find a way to migrate that actual Armitage or Interpreter, whichever executable, from my current program over to the infected machine, then let's see if we can find a way to have that reverse shell have it connect back out to Armitage. If that is possible, I will be really happy. So let's see. Let's see if that will work for us also. So if you click on Command Terminal, this is the one system that we have that connected back to us from the infected machine. Then you click on Migrate Payload. So if we click on Migrate Payload, this can be any executable that you want to send over to that machine. So it can even be Mimikatz or PWDump, whatever it is, you can send it from Splinter. So if I go to binary, okay, that should work. And let me go back to Kali. Okay, so right now I have Armitage, I have a listener up and running, and I'm just waiting to receive a connection. So hopefully I can migrate that reverse interpreter onto the infected machine and then have it connect out to us on this side, if that is successful. So let's see, if I click on open, I'm not going to give it any additional arguments, and I do want it to execute upon completion. I'll hit launch. So the program says, okay, it sent it over. Let's see if we get a new connection. Hopefully this is going to work. Let's give it a second. Okay, great. Okay, so now what we just demonstrated simply was, it was very quick and painless, is that if you're going to create your own malware, don't just limit it to only using your own commands. If you can find a way, determine how I can send additional commands over to that infected machine, and then execute it. So how would that look like in terms of code? Well, it's very simple. If I have a binary or any file, and I start to read it in the file in chunks, I already have a socket established to my implant that I can send and receive commands. So what I will do is I'll take that binary data, I will encode it, I will now send it over to that infected machine, decode it, write it out to disk, and then execute it. And hopefully if we are successful, we can just find out that we can migrate additional tools onto that infected machine. Okay, so we already did that, we did that. Okay, now, score serve. This I use in terms of additional things. What else do I want to do one time on that infected machine? So if I say that, let's look at DOSing. If I want to talk about a DOS, and I say, okay, how do we define a DOS? In fact, Dutch, right? Yeah. What is DOS? How would you define what a DOS is?
You take out the service that whatever your target is delivering to people, then yeah, that would be denial service.
Okay, good, very good. So in fact, I think most of us can agree that a DOS, we will agree, is denying service. And we simply say we're sending too much information that the other system can handle, so it crashes or so. So that's a good definition, but in and of itself, it's insufficient. Because now, if we are the developers of malware, if we are the person actually programming it, simply tell me that, oh, just send too much information over to a system. How do I send too much information over to a system? Furthermore, how do I know what type of information to send and what type of information not to send? Because if I'm connecting over to a web server is pretty good at not sending information it doesn't have. So if I were to say, okay, give me various bogus web pages that the web server doesn't even serve, it doesn't have, it's just going to deny that connection. But instead, if we can think of a DOS as resource starvation, in which let me find a way to talk to that server and now say, please, give me good information that you have. Whatever is your index page, go ahead and send me an index page. And the server will generally send you an index page. But what if a system comes back and says, thank you for the index page. Please send me the index page. What will the server do? It will send you the index page, right? So what if I then say, okay, thank you very much. Please send me the index page. What will the server do again? It will send me the page. So what happens if I can do this many times? And furthermore, what happens if I can get many other agents to do this all at the same time? Then actually, I can find out that I can discover a way to consume all the available resources on that server, so I can now, at a minimum, degrade access to the system, and at a maximum, I can disrupt it. So let us see how that works. DOS techniques, procedures. Okay, let's do another demonstration here. Okay, so hopefully our DOS is going to work okay. I hope so. I hope so. I really hope so. Okay, you can tell. Sometimes this stuff just doesn't work right. So I'm going to use Ether 8. Have we heard of Ether 8 before? It's simply just a tool that I can use to, it's like good eye candy. I can just use it to monitor the network. Okay, so I have Ether 8 on this side, so you can just see that these are various connections to a web server. And the web server, let's use an FTP server. I think that looks better. I like that agent. The FTP server is running on this Windows machine, and it should be at, if I do the IP. Okay, so the IP address is 192.168.223.139, and I'm just using FileZilla right here to run my FTP server. Okay, so if you do want to try and deny access, I created two DOS agents for this botnet. One is denying a website, and then the other is denying for FTP. So let's see how the FTP agent will work. If you go over here to the shortcut commands, and then you click on DOS FTP server, I try and make it as easy as possible to implement your DOS. All right, so let's go over to the left. The IP address or URL that I want to go after is 192.168. What was it, 223.139? Okay, you can leave these standard. And now the username, I will try and log in as anonymous. And then after anonymous, I will use just a blank password. So that's just the protocol whenever you want to say, okay, have my controller go ahead and DOS that website, or the FTP server in this case. And now, if I'm successful, what command do I want it to execute? I would just say execute a listing command on the FTP server. So good. So as you can see on the right side, I'm getting many connections to the server, and it's not Ether 8 is not showing up on this side. Okay, let me stop this because it's not as beautiful. Okay. Okay, so what I'm doing, I'm simply telling another Splinter agent, okay, to connect over to my controller, so I can just be able to see the traffic easier, I'm hoping. Okay, so now I have another connection to the controller, and now I'll just simply implement the same command. And hope, okay, there it is, there it is. Okay, so now it's showing up. So what is actually happening? I created multiple threads on the agent. So any time that I tell the controller, okay, go ahead and start to DOS the system, I'm now instantiating thousands of threads all at the same time. And they start to grow and get bigger and bigger and bigger. To connect over to that FTP server, let me go ahead and try and authenticate with you. If I can't authenticate, I will try and authenticate again. If I can authenticate with you, I will try and continue to send listening. I'm simply sending multiple commands so now I can start available resources on that FTP client. And then I give you status at the right side to say, okay, what is my connection size? So right now we have about 200 connections established. Okay, well that was faster than I thought. Okay, so some things just work faster than you expect. Okay, so in this case, I guess part of a distributed system is whenever I send commands over to an agent, I would like it to give me feedback that, okay, the command was executed successfully, or something significant has just happened. So in this case, whenever I told my agents, go ahead and start to DOS a website, or start to DOS FTP, how do I know when my DOSing is finally becoming effective? Well, that FTP server should actually start to say, no, it's too much. I have too much, stop sending me connections. Stop trying to connect to me because I am consumed right now. So in this case, this is actual status that one of our agents reported back, and it says, FTP DOS status code 421 for FTP is like you have too many connections or so, or was denied by the server. Yeah, so this is what the server responded back. Too many users are logged in for this account. Try again later. So in one instance, we can say that, okay, our FTP DOSing is working. Let's go back. Yeah, and there's still, the DOSing is still going on until that server is done, until it crashes. And if you do actually start the DOS, delete all of this. Okay, and then if I click halt, because you see the DOSing still going on. If I halt it, they should respond, okay, I received a kill command, and then they should terminate all of their connections over to the server. And now anyone else should be able to log back into that FTP server once again. Okay, let's go back. There was one set of slides that I did want to talk about, and that's an actual beacon agent. Yes. Okay, so if we want to talk about stealth and persistence, how do we maintain access to a system? The inspiration of this actually came from Raphael Mudge, and that last year we were at Hacker Halted, or this year, I think it was last year, we were at Hacker Halted, and then he said, sometimes just maintaining a persistent connection to an infected machine for a prolonged amount of time can be indicative of malware infection. So instead, create a way to have your agent start to beacon out to my command and control server to let me know, okay, is it time to execute a command? If it's not time to execute a command, sleep. Serve that actual connection, and then try it again. If you can do this multiple times, then you can maintain access to a computer system without having a prolonged established socket. So this is the general concept of what happens. The first thing that goes onto the system, the implant infects the victim box. As soon as he infects the victim box, he goes over and registers to the controller. Once he registers to the controller, he simply says, I am live, I am active on this infected machine. The controller acknowledges, and then the connection is severed. And now the agent goes to sleep. So for every period amount of time that he specified my agents are going to sleep for, the agent does not have a pre-established connection to the controller. He wakes up and then says, controller, do you have a command for me to execute? The controller says no. Okay, I'm going to go back to sleep. Controller, do you have a command for me to execute? The controller says no. I'm going to go back to sleep again. Controller, do you have a command for me to execute? Yes, send me a shell. Okay, fine. I'll go ahead and send a shell. So how does that look like, okay, for my infected machine? So finally, the victim will actually wake up. He says, okay, are there any more commands to execute? If so, go ahead and spawn a shell. If I do receive that command, I'm going to send a shell right back to that infected machine. And now, again, I have my command and control without having that prolonged established connection. So if we want to establish this in our infected machine, let us see how to do so. Okay, let me clear the screen. Okay, again, so we're using the Splinter implant. If you use the -H, I also show you all of the commands and all of the capabilities of this Splinter version. And this one is 1.41, and I'll be uploading 1.42 again as soon as I get back home. So if we use the -B, that's going to say that that's the beaconing that I want to use and establish a connection over to my infected machine. So I'm going to say Splinter -B, and then it's the IP address to the controller, 192.168.223.1, I think, on port 8080, and then the beacon, the sleep interval. So right now I want to say sleep every 6 seconds. Did someone, was there a question?
That address up there looks funny. 192.0.
Oh yeah, looks like I fat fingered something.
Yeah, that's
Sorry.
probably NSA.
Yeah, okay, that's we don't want to do that. Okay, so yeah, 192.168.223.1, 1, and then the wait interval. In this case, I'll use 6 seconds just so it's fast. And that looks to be successful. Let's give it another few seconds and see if he will talk. Okay, it looks like he is beaconing. So let us go to the controller again. And now if we click on beaconing agent, every 6 seconds we should get a new request from the agent saying, okay, are there new commands to check in? Oh, good. So it is working. I was scared. I was like, whoa. You know, I guess 6 seconds seems longer than every time here. So anyway, the agent is waking up saying, are there commands to execute? If so, give it to me. I will execute them and then return a response. So let's just do one. Let's say ipconfig. And if you do want to load additional commands, let's say you're doing your pen test, and I want all these commands to be executed whenever I have a victim exploited with my implant, you can click on Add Command right there, and then now you can start to queue up all of your commands that you would like. So I'll say netstat -ano. Any other commands someone would like to execute? I did ipconfig netstat task list. Let's do task list. Okay. Task list. All right, now, as soon as if I want to enable them, I just click on the enable. And the next time the agent checks in, he's going to execute the commands and then send it. Okay, so I'm glad that was working okay. So the agent has checked in, he downloaded all the command list, he executes the commands, and he returns it back to me. And so he's going to do that as long as you have multiple commands enabled for the agent. And once you are finished with that, if you disable all the commands, upon the next time, he's going to stop sending you information, eventually, and then he'll go back to sleep. As soon as he sleeps, he wakes up to see if there are new commands. No commands, so he just went back to sleep. So that's just another feature that we implemented with our actual agent system. Let's do another one. One thing also is always, when is it time to establish a shell to our controller? That's what we're using with our beaconing agent. So if I go back to active connections, I have, I think it's 1. It should be 1. Oh, 2 connections. Okay, so I will now tell the agent, give me a shell upon the next time you connect. So if this is successful, I should end up having 3 connections here. Simply that the agent is responding whenever I say, give me a shell. Okay, so let's go to beaconing agent, and now I'm just going to use a shortcut, establish shell. And I'm going to enable it. I'm going to wait till he checks in. Okay, he just checked in. So hopefully, like within the next 4 or 5 seconds, we should get a new shell to the control. Okay, so that worked okay. Again, and that's simply that as soon as the agent checks in, he sends a shell. He provides a shell, a terminal that I can execute commands back and forth with. So how do you actually program this? And it's simply as I said before. If you're using worker threads, your worker thread is simply a thread that waits to execute whatever command you want for a predetermined amount of time. So if I have various threads that are waiting, sleeping, and waking, check if I need to establish a shell, check if I need to execute a command. If so, execute. If not, go back to sleep again. That's exactly the main purpose of a beaconing agent. And the important thing, whenever I was working in network security, I always used to hear that, we have beaconing activity on our network. And beaconing activity is really, really, really dangerous, in my opinion, because it says that, okay, not only are you infected, but you're infected with someone who might have an idea of what they're doing in order to know that I'm not going to keep a pre-established connection. Instead, I'm always just going to check in randomly whenever it's time to execute a command. So if you understand how to do this, go ahead and look at the traffic in Wireshark, or look at the traffic in Snort to now determine how can I find this activity on my enterprise, and now how can I stop it. That's, again, the main purpose of creating Splinter. And the main purpose of creating these things is, let me understand how to exploit the network, and then let me understand how to better secure it. Okay, so there are additional features. Yeah, so there are additional features, but definitely this time I always go over. I always go over. So today is my plan not to go over unless we have additional questions in the presentation. So these are additional features that we can talk about, additional features that I built into Splinter that we can say, how does the code look? How does this work on the network or so? Or I can just say, these are features that I release tutorials on Twitter so you can understand how to use Splinter and also how to read the code. So let's move over into questions, and then if you want to see more, I'd love to do more, because that's why I'm here. I'm here to help everyone and show you the work that I've done very, very quickly. So the final thought, let's always develop better ways to secure our systems, and one of the best ways is to understand this is by exploiting our current resources. So questions, which questions can I answer? Oh, yes. Joe. Right, I have encoding enabled that inside the controller you can say I want to encode, or I have not released the encryption module simply because I want to keep it unencrypted until I've spoken about this for a while, then it's just going to be encrypted. But yeah, I've already built encryption in, which is like hacking 101. Great question, as Joe mentioned. Do we have encryption in our command and control? I did not do it yet, but it's already there. I just wanted to talk about this enough. And then, like, version 1.6 will have encryption and encoding enabled. Because again, it's 101 as your command and control should have it. So yeah, you're absolutely correct. Yes?
Solomon, did you say what language you've written this in?
This one, the controller is written in Java, simply because the controller is running on our side. You can write your controller in any language. The implants that we saw here is written in C++ and also in Python. And I have implants in Java. The ones that are online are in Java, but I have Python.
What about the dropper?
This dropper was written 2 days ago, so I wrote that in Java. It's going to be converted into C++. Yeah. Simply because it was like, well, how would I do that? Okay, I'll use the language I know best. Yes?
So you're using Python for your agents?
Right, the agents, most of the agents mainly.
How are you doing that?
I use Eclipse. Well, what do you mean compiling? Oh, you mean converting it to executable?
Yeah.
I use Python to exe.
Okay, I want to talk about this.
Okay.
I do something else similar.
Okay, I love that. So, I mean, again, it makes our capabilities better. And I released the source code fully. It's fully free. Even with comments, imagine. So at least, you know, it's there to help people. Yeah. Well, oh, yes, James.
What is Splinter license?
New? I believe I put a new public. It's in fact. Let's see. So your question is, what is the license under? Let's see what the copyright is. I should still be connected. Let's go back. Releases, copyright, software, right there. New public license. So again, source code, everything is freely distributed to all as love from me. Yeah. Any other questions? All right. I really thank you for your time. If you have additional questions, especially on the actual programming or the coding, you know, I'm here in the back. I'll either be there charging my laptops or in the back over here, so we can talk much more about it. But I hope it was helpful. Please go through the site here and look at the tutorials, because I try and do just quick and easy how do you get your exploitation to work. Python right there. Getting set up. Yeah, so I just do images on how would you enable whichever function inside Splinter, and I just make it just simple for you to use and learn from, and then exploit the network as you would like. Yeah, thank you so much again. Thank you. Hope you have a good day.